So, after Watson and Crick, the two fathers of genetics, with the much forgotten mother of genetics being Rosalind Franklin, you had the next big question, which was, how does DNA actually replicate? Is it conservative, where the old strand or the parent strand stays as the parent strand, and you get a whole new strand, and then again, parent strand stays as the parent strand, and a new strand is formed? Or is it the fact that this strand splits up, this one acts as a template for this one acts as a template for this one, you get half and half new, half new, half old? Or is it sort of this weird, slightly random mixture where you got a little bit of new, a little bit of old, a little bit of new, a little bit of old, sort of thrown together, which is known as dispersive? It was semi-conservative. You should know that it's semi-conservative, but this is the experiment that proves it, and this is the question they like to ask because it shows a little bit of experimental understanding. The people who did this were Mieselson and Starr. Look at those handsome fellas. So what they did was actually an incredibly simple experiment, and they just grew bacteria in normal nitrogen. So DNA has huge amounts of nitrogen in it, so the nitrogenous bases are called the nitrogenous bases because they are highly nitrogenous. So they grew it in a growth medium, so all the sort of nutrients that the bacteria could use were N14, which means that these bacteria then had DNA that was sort of N14 heavy. It was heavy to the point that only N14 was involved. But then the genius thing they did is they grew it in N15. So they grew it in N15, so they just moved it over. So take it all the N14 away and grow it purely in N15, which means that when they have to grow and do the next round of DNA replication, the only nitrogen available is N15. So it will give us clues as to what's going on. If it is semi-conservative in its replication, the next generation after this growing in here will have 14.5. On average, their DNA will weigh 14.5 because half it's 15, half it's 14, and it's equal. It's bang on 14.5, and that's important. It's bang on 14.5. If it's conservative, if it were to be conservative, you would have one strand that's 14 because that's the original strand, and this new purely 15 strand. And finally, if it's dispersive, so this sort of random, this bit's new, this bit's old, this bit's new, this bit's old, it would most likely be roughly 14.5. But because it's slightly random in which bits are new and which bits are old, it would be roughly 14.5. It will sit, don't get me wrong, it will sit mostly around 14.5. The 14.5 will be the mean, but you are going to have values either side of it, and that's a really important point. It's a hard point, but it's an important point. So they just did that, and they grew it. So they grew these bacteria, they then blended them, and then centrifuged them, and saw how many bands you would get. And this is what the results look like. So this is the DNA. And, let me get rid of that. And this is what they found. They found that it was one line. They had a 14.5 line. They did not have a 15 line, a 14 line. And they didn't have these various values around 14.5. So it wasn't that. They proved that DNA replication was semi-conservative.